Space is one of those topics where almost everything you think you know is wrong. From basic facts you learned in school to stuff movies have been drilling into your head for decades, the misconceptions run deep. Today, we're correcting every single one of them, and we're starting with the one that still makes people genuinely angry. Pluto is still a planet. Look, I get it. We all felt personally betrayed on August 24th, 2006, when the International Astronomical Union officially reclassified Pluto as a dwarf planet. But here's the thing, Pluto meets two of the three criteria for planethood. It orbits the sun and it's round, but it has never cleared its orbital path of other debris, which Earth, Mars, and Jupiter all do. Pluto shares its neighborhood with thousands of other icy bodies in the Kuiper Belt. It's also smaller than our own moon, 2,377 kilometers across compared to the moon's 3,474. Nobody demoted Pluto out of cruelty. Science just got more precise. And honestly, this is the most forgivable mistake on the entire list because it came from real education, not ignorance. But if you think losing a planet was a rude awakening, wait until you hear what people get wrong about the moon. The moon has a dark side. Pink Floyd accidentally taught millions of people incorrect astronomy, and nobody noticed for decades. The 1973 album is a masterpiece. It's also completely wrong about the moon. Here's the thing, the moon doesn't have a dark side, it has a far side. The moon is tidally locked, meaning its rotation period of 27.3 days exactly matches its orbital period. So the same face always points toward Earth. But the side we never see, it gets just as much sunlight as the side we do. It's not dark. It's just hidden from our view. The Soviet Luna 3 probe photographed the far side for the first time in October 1959, and what they found was actually the opposite of dark. The far side is rockier, more cratered, and in some regions literally brighter than the near side. Dark in this context always meant unknown, not lightless, but one legendary rock album blurred that line permanently. And if a word can trick millions of people about the moon, wait until you hear what basic intuition gets wrong about the seasons. Seasons and distance. This one sounds so logical that you can't even blame people for believing it. Closer to a heat source means warmer, right? That's how campfires work. That's how ovens work. So obviously, summer happens when Earth is closest to the sun, except Earth is closest to the sun in January, right in the middle of Northern Hemisphere winter. The exact opposite of what distance-based logic would predict. Here's the thing, Earth's distance from the sun only varies by about 3.3% across the entire year. That's basically nothing. The real driver is Earth's 23.5-degree axial tilt, which changes how directly sunlight hits each hemisphere throughout the year. Tilt is doing everything. Distance is doing almost nothing. And this isn't some niche misunderstanding. Over half of adults believe distance is the primary cause of seasons. It's one of the most widespread scientific misconceptions on the planet, literally. And most people learned it wrong in school, so it's genuinely not your fault. But if you think confusing orbital mechanics is bad, wait until you hear what people think shooting stars actually are. Shooting stars. Humanity has been wishing on tiny flecks of space gravel for thousands of years. And honestly, that's kind of beautiful. A shooting star isn't a star, not even close. It's a meteor, a particle of dust and rock usually between 1 millimeter and 1 centimeter in size, slamming into Earth's atmosphere at speeds up to 72 kilometers per second. That's over 250,000 kilometers per hour. And here's the part that genuinely surprises people. The glowing streak you see isn't the rock burning up. It's the air around it being superheated to thousands of degrees. The atmosphere is doing all the work. Most of the actual particle survives and just becomes part of Earth's accumulated cosmic dust. Meanwhile, real stars are enormous nuclear fusion reactors sitting light years away. They don't fall. They don't move across your sky in a half a second. The name itself is the lie, and nobody ever told us to question it. The best part? Major meteor showers like the Perseids in August and the Geminids in December aren't random. They're completely predictable. Earth passes through debris trails left behind by celestial objects right on schedule every single year. Most showers come from comet debris, but the Geminids are the weird exception. Their source is actually an asteroid called 3200 Phaethon, which makes them one of the most unusual meteor showers we have. But if wishing on space dust sounds silly, wait until you hear about the myth people have been repeating about a certain wall, the Great Wall of China. This one is genuinely hilarious when you think about it. People confidently repeated this fact for decades before a single human being had ever been to space to check. The claim goes back to at least 1932, when it appeared in a Ripley's Believe It or Not cartoon. Robert Ripley stated it as fact, and millions of people just ran with it. We didn't send anyone to orbit until 1961. That's almost 30 years of everyone just taking his word for it. Here's the thing, the Great Wall is long, absolutely, but it's only about 4.6 to 9.1 meters wide. That's roughly the width of a highway, and its color blends almost perfectly with the surrounding terrain. From the International Space Station at 400 kilometers up, astronauts have repeatedly confirmed they can't see it with the naked eye. NASA has officially debunked this claim multiple times. You know what is visible from space? Roads, parking lots, urban sprawl. Humanity's greatest architectural achievement is invisible from orbit, but a Walmart parking lot lights up like a beacon. The wall is still incredible. Nobody's arguing that. But the visibility claim was dead on arrival the moment we actually got up there to look. Now, speaking of things people misunderstand because of a single misleading word, let's talk about light years. Light years. This one is a language trap, and honestly, it's hard to blame anyone for falling into it. A light year sounds like it measures time. It has the word year right there in the name. But a light year is a unit of distance. Specifically, it's the distance light travels in 1 year, roughly 9.46 trillion kilometers. And that distinction matters more than you think. The nearest star beyond our sun, Proxima Centauri, is 4.24 light years away. That sounds manageable until you do the math. 4.24 light years is approximately 40 trillion kilometers, not 4.24 years of travel. 40 trillion kilometers of empty, freezing nothing between us and the closest star. That number should feel incomprehensible, because it is. Science fiction makes this worse. Characters casually say they're traveling 12 light years like it's a flight time. Not a distance so absurd your brain physically cannot picture it. Time in astronomy is measured in seconds, minutes, hours, and years. Just like everywhere else, light years are purely a distance tool with a deeply misleading name. But if you think the distances between stars are hard to picture, wait until you hear how wrong everyone is about the asteroid belt. The asteroid belt is densely packed. You can thank Star Wars for this one. That iconic scene in The Empire Strikes Back where Han Solo weaves the Millennium Falcon through a field of massive rocks smashing into each other? Pure fiction. Entertaining fiction, but fiction nonetheless. Here's the reality. The asteroid belt between Mars and Jupiter spans roughly 550 million kilometers. It contains over 1 million asteroids larger than a kilometer. Sounds packed, right? But the average distance between those asteroids is somewhere around 1 to 3 million kilometers apart. If you were dropped randomly into the asteroid belt, you would see absolutely nothing. Just black, empty space in every direction. NASA has sent multiple spacecraft straight through the belt since 1972. Not a single one has ever come close to hitting anything. Not because of fancy navigation, because there's nothing to hit. The belt is basically an empty highway with a few pebbles scattered across several lanes. But if Hollywood lied to you about asteroids, wait until you hear what they got wrong about gravity in space. There is no gravity in space. The International Space Station experiences roughly 90% of Earth's surface gravity. 90%. Almost the same gravitational pull you're feeling right now. And yet everyone who watches astronauts floating up there assumes there's no gravity in space. That's completely wrong. Gravity extends infinitely. It weakens with distance, but it never disappears. The ISS orbits about 400 kilometers above Earth, which is basically nothing in cosmic terms. Gravity is fully operational up there. So why are astronauts floating? Because they're falling constantly. The ISS and everyone inside it are in perpetual free fall toward Earth. But they're also moving forward so fast that they keep missing the planet. They fall, Earth curves away beneath them, and they just keep falling and missing forever. That's what an orbit actually is. It's not the absence of gravity. It's gravity doing exactly what gravity does. The whole misconception comes from confusing weightlessness with no gravity. Jump off a diving board and you feel weightless too. Gravity didn't vanish. You're just falling with nothing pushing back against you. Astronauts experience that same thing, except their fall never ends. But speaking of space exposure, if you think the gravity misconception is bad, wait until you hear what people think happens to your body without a spacesuit. You would explode without a spacesuit. This one is almost entirely Hollywood's fault, and at some point we need to talk about it. Every sci-fi movie shows the same thing. Someone gets exposed to the vacuum of space and their body pops like a water balloon. Dramatic, cinematic. Completely wrong. Here's the thing, human skin is way stronger than people give it credit for. It's a pressure vessel. Your body is fully capable of holding itself together in a vacuum. You would not explode, not even close. What actually happens is somehow both less dramatic and more disturbing. You'd lose consciousness in about 15 seconds from oxygen deprivation. Dissolved gases in your body fluids would start forming bubbles, a condition called ebulism, basically the worst case of the bends imaginable. Water on your skin and tongue would begin to boil, not because it's hot, but because the boiling point drops to body temperature in a vacuum, and then you'd just quietly die. No pop, no bang. About 3 minutes of hypoxia and it's over. The real version is a slow, silent shutdown, and honestly, that's way creepier than any movie explosion. But speaking of silence in space, the next misconception takes that concept to a whole new level. Space is completely silent. This one sounds right, and technically it is right. But most people misunderstand what silent actually means in this context, and the difference is genuinely fascinating. Sound is a pressure wave. It needs a physical medium to travel through. Air, water, solid material. The vacuum of space has essentially zero molecules to carry those waves. So there's no sound, but here's the thing, space isn't silent the way a quiet room is silent. A quiet room still has air. Sound could exist there, it just isn't happening. Space is something weirder. It's acoustically null. The entire concept of sound doesn't apply. It's like asking what color a thought is. The question itself breaks down. One piece of Hollywood actually nailed this. The tagline from Alien in space, "No one can hear you scream," is perfectly accurate physics. Meanwhile, every other space movie gives you roaring explosions and engine rumbles in the vacuum. Alien got it right and used it to terrify you. Respect. Now, you've probably heard those NASA recordings labeled sounds of space. Those are real data, but they're not sounds that existed in the vacuum. They're electromagnetic waves, converted into audio frequencies so human ears can process them. It's a translation, not a recording, but if the silence of space seems eerie, wait until you hear what people get wrong about black holes. Black holes suck everything in like a vacuum. This is probably the most universal believed myth on this entire list, and it's completely wrong. Black holes don't suck, they don't pull, they don't vacuum. They're just incredibly massive objects with extreme gravity, following the exact same gravitational rules as every star and planet in the universe. The only difference is they're compressed into an absurdly small volume. Here's the thing, objects can orbit black holes perfectly safely, the same way Earth orbits the sun without spiraling into it. A black hole is passive. It's just sitting there. It only captures objects that cross its event horizon, the point of no return. Everything outside that boundary, completely fine. And here's the detail that breaks people's brains. If the sun were instantly replaced by a black hole of equal mass right now, Earth's orbit would not change at all. We'd keep orbiting at the exact same distance, at the exact same speed. We'd lose the light, sure, but we wouldn't get pulled in. The gravitational effect at our distance would be identical. The cosmic vacuum cleaner image comes from movies and lazy science communication, not actual physics. Black holes aren't monsters or anomalies. They're just very, very dense masses doing exactly what gravity has always done. But speaking of things we get wrong about space every single day, let's talk about the object you literally look at more than anything else in the sky. The sun is yellow, the sun is green. Technically, its peak emission wavelength sits at roughly 500 nanometers, which falls squarely in the green part of the visible spectrum. That sounds completely absurd, but the physics doesn't care about your feelings. Here's what's actually happening. The sun emits light across the entire visible spectrum, and when all those wavelengths hit your eyes together without interference, the result is white. Not yellow, not green. White. Astronauts confirm this every single time they look at it from orbit. Above Earth's atmosphere, the sun is a blazing white disk, no hint of yellow anywhere. So why does everyone on Earth see a yellow sun? Blame the atmosphere. Rayleigh scattering strips shorter wavelengths, particularly blue light, out of your direct line of sight and scatters them across the sky. That's why the sky is blue and the sun shifts toward yellow. especially near the horizon where sunlight passes through more atmosphere. But here's the real reason this misconception refuses to die. It's not a lack of evidence, it's cultural saturation. The yellow sun appears on national flags, in every classroom drawing you've made since kindergarten, on emoji keyboards, in textbook diagrams on cereal boxes. The wrong answer has been repeated so many billions of times that it doesn't feel like a misconception anymore. It feels like a memory, and memories are almost impossible to overwrite. But speaking of the sun, most people also think they know what's powering it. They're wrong about that too. The sun is on fire. This is the big one. The misconception so deeply embedded in our language, our art, and our understanding of the sky that most people never even question it. The sun is on fire. It's a giant ball of flame, except it's not even close. And the difference between what the sun actually does and what fire actually is might be the single most dramatic gap between assumption and reality on this entire list. Let me explain. Fire is a chemical combustion reaction. Now, it requires two things, fuel and oxygen. That's it. No oxygen, no fire. The sun's core operates at 15 million Kelvin. There is no oxygen involved in what's happening down there. Combustion is physically impossible at those conditions. What the sun actually does is nuclear fusion. It takes hydrogen atoms, smashes them together with so much force that they fuse into helium and releases an absolutely staggering amount of energy in the process. That's not burning. That's not even in the same category as burning. Here's the detail that puts this into perspective. Physicists in the 1800s actually ran the numbers on this. They calculated that if the sun were powered by chemical combustion, literally burning fuel the way a campfire does, it would have exhausted everything it had in roughly 5,000 years. That's before recorded human history, before civilization, before we ever existed to look up and wonder what that bright thing was. The sun is 4.6 billion years old. It has another 5 billion years of hydrogen left to fuse. That lifespan is only possible through nuclear physics. Combustion can't even begin to explain it, and the scale isn't even comparable. The sun outputs 386 billion megawatts of energy. No chemical reaction in the universe could produce that. Fire at the sun scale isn't just wrong. It's like comparing a matchstick to a nuclear warhead and calling them the same thing. The sun isn't on fire. It never was. It's doing something millions of times more powerful, and the fact that we still call it burning might be the most casually wrong thing humanity says every single day. If you enjoyed this video and want to see more, click the video on the screen now.